Hello, welcome back to my AP Calculus class. I will keep explaining definite integration from example 18. I solve just three example problems a little slower because these three problems is very important, I think. Let's just start from example 18. If large fx is given like this, integral 0 to cosine x equal to 1 minus t cubed dt, and we're going to find that derivative of that large fx. That means d over dx integral 0 to cosine x square root 1 minus t cubed dt. If you let this part square root 1 minus t cubed, that part is small f of t. Then, if you find that integral over this small f of t, let that integral small f t dt, you don't have to find it. Just define that as a large ft. So if this part is small ft, integral of small ft is a large ft. So that is a large ft from 0 to cosine x. And then d over dx. So d over dx, well, you have to find the derivative of f prime of it, derivative of a large fx. That's why I put d over dx, right? Now, how can you find that in the definite integration value? Plug in top number minus plug in bottom number, right? So large f of plug in cosine x, cosine is upper limit, and then minus large f of 0. And then find, okay, these two parts derivative, d over dx of f of cosine x. Large fx is small fx is integral, so large fx is derivative is what? Small fx, so small f of cosine x. And then it has inside the function cosine x. By the chain rule, we have to find that derivative of the inside the function. What is the derivative of cosine? It's negative sign. Put the negative sign in front and then sign x. And then any number's derivative is 0. Okay, so that is small f of cosine x times sine x. What was small fx? Small ft is this, right? So plug in cosine x into the small ft, square root of 1 minus t cubed. But now plug in cosine x for t. So cosine cubed x times sine x. This is the final answer. Okay, let's go to number 19. Number 19 says limit h approaches to 0, 1 over h integral x to x plus k, x plus h, square root of 2 e to the t powers minus 1 dt. Okay, I'll change just a little bit. I change it like that. Limit h approaches to 0. I put whole things the top x to x plus h, square root e to the t minus 1, and then the bottom is h. If this part is small f of t, integral of small f of t is a large f of t, and then plug in upper limit minus plug in lower limit. So large f of x plus h minus large of f of x over h and limit h approaches to 0. This is exactly what? Definition of derivative. This is f prime of x definition, right? So it is kind of large f prime of x. Is a limit definition of derivative. So large f prime of x means small fx. What was the small ft? We let square root e to the t powers minus 1 is be f of t. So f of x equals what? Square root e to the x minus 1. This is the answer. Okay. Next, number 20. Integral 3 to 6 x times square root x minus 2 dx. We can find this, we can use u substitution. Last time when I used u substitution, I find indefinite integration first in terms of x, and then plug in top number and minus plug in bottom number. I used it that way. But today, I will just to find the indefinite integral, not in terms of x. I just in terms of u, and then I use two u values instead of x values. I'm going to use u values for lower limit and upper limit. I show you how to do that. At first, u part in this problem here, I let square root x minus 2 equals u part. Okay, and then I'll put square both sides. Squared. That means x minus 2 equals u squared. So x equals u squared plus 2. Okay, so this is going to be changed to integral x times square root x minus 2. X is equal to u squared plus 2. Why I do that? I change all x function to u function, and then square root of x minus 2, that was u part, u. You can change dx to du, right? Dx to du. So what is dx equals? Find the derivative of this part, right? That means 1 over 2 square root x minus 2, and then dx equals du. Du is always 1 over derivative of u part, this one, right? Derivative of u parts. So 1 over 2 radical x minus 2 du. If you simplify this a little more, integral u squared plus 2 times 1 over 2 is 2, right? That's 2. And then that is 2 times square root x minus 2 du. What was this part? That part is u part, right? So I changed that to u. So u squared. So 2 integral u squared plus 2 times u squared and du. And that makes sense, right? And then last time we found the integral of this function, and then we used just the 2x values, right? But I'm not going to use x values anymore. So I'm going to change these two x values, 1 and there was 3 and 6, right? I changed these two x values to u values. If x equals 3, plug in 3 here. 3 minus 1, square 3 minus 1 is u, that's 1. So 1, 2. If x is 6, radical 4, that's 2. So 1 to 2, 1 to 2. That makes sense, right? We just change x value to u value using the equation square root x minus 2 equals u. And then still use that 2 here, and then find that integral of this part, which is going to be integral u to the 4th plus 2 u squared du. 1 to 2. 1 to 2. Then that is equal to 2 times 1 over 5 u to the 5th plus 2/3 u cubed by power 1 to 2. So 2 times, plug in 2 first. It is 32 over 5 plus 16 over 3. And then minus, plug in 1. 1 over 5 plus 2/3. Okay? If you calculate this, you can use a calculator. They're going to be answers, right? But sometimes you have to find the value, because sometimes in multiple choice problem, just they ask you some forms like, some choice looks like this, or the choice looks like this. But if you have to find the value, you can find this value. You can use a calculator. Okay, I'm done today. I keep explaining from example 21, the next video. Okay, thank you so much for watching my video. And please click subscribe and like and turn on the notification. Thank you again. Bye-bye.